Yeah, so my name is Daniel. I work at Reddit on the infrastructure team. And so today I'm here to talk to you about our April Fool's project, which was called r/place. Before we get started, I wanted to get a show of hands of who here actually got a chance to play the game and remember it. And yeah. Okay, cool. So maybe 50-50. So just as a background, so everyone's on the same page, I'm going to start by talking about what the actual project was. And for those of us who played it, we can maybe reminisce a little bit since it's been a couple months. And I personally miss it. So what was r/place? The idea behind it was individually you can create something, together you can create something more. So what it was this globally shared canvas where it was a 1,000 by 1,000 pixel grid. Anyone could come in and place a pixel once per 5 minutes. That was the key. So by yourself, you only got about 12 pixels an hour. Which obviously is not enough to actually draw much. But if you work together with other people, the idea was you could do something a lot bigger. So we didn't really know how this was going to turn out. I personally was skeptical that even 10 people could get together and draw something. So I was really surprised and happily surprised to see something like this take place. So this is a time lapse of maybe 6 hours in up to a couple days in. And so you can see people really drew amazing things, far beyond anything that I personally expected. So you can see there's national flags on there. There's stuff for different subreddits. People made stuff just for this too. So one of the coolest things to me was that if you look in the middle, there's sort of a rainbow that's kind of sprawling about the map as the game progresses, and they called that Rainbow Road. And I was lucky enough to be on call for all this, so I had an excuse to sit at home on a Friday night, and I got in their Discord channel, and I kid you not, there was literally 1,000 people in there all coordinating to make this thing. And so within that Discord, they had sub-factions of people dedicated to construction, so they had a construction channel for making new stuff. They had one for maintenance, for warding off vandals, which, it's the internet, so vandals are gonna be there. They had a diplomacy channel. So as you can see, they're kind of sprawling around. They're running into other drawings. So they had diplomats that they were sending out to other Discords and other subreddit chats to say, hey, we don't want to hurt your drawing. Should we go around you? Should we integrate it somehow? So I mean, the level of self-organization was just amazing. That was just one Discord chat. I saw people's Twitch streaming. At the bottom, you can see some red coming in there where people were trying to attack the blue corner on a Twitch stream. But it was kind of fun to see all that break out. And so here's a snapshot of the final canvas. So as you can see, there's almost no space left. In the end, we had, I think there was something like 2,000 to 4,000 pixels that had never been touched, but they're basically just white pixels that make up some of the Linux penguin there. So some big numbers from this. We had 1.1 million unique users use it. We had, I think at peak, we had something like 150,000 concurrent connections and people actually playing at a given time, which is about what we expected. We were expecting, based on previous April Fools, something like 100 to 200,000. And then 16.5 million pixels placed, and it all happened over the course of 72 hours. So there's a lot of stuff going on in just 3 short days. So that's kind of a background of the actual project. What we're going to do now is go into some of the challenges that we went into when we were making it, and then we'll get into the how we actually built it and what tech we used and Redis, obviously. So some of the challenges that go into a project like this, it's pretty unique. So the first thing is we're all used to software projects having a deadline, but this is sort of there's a very hard deadline of April 1st. Reddit has a history of April Fool's projects like The Button and Robin. And you can't really be oh, it's April 1st, we're not ready, so let's do it on the 14th this year, or something like that. So it has to be ready to go, and it has to be ready to handle all the load they're going to throw at it. So the other side of that is, okay, so sometimes you can, we all have deadlines, and maybe you launch a project and it gets off to a rocky start, but you can kind of improve that over time. For this, it's we only plan to run this for a few days, so if it kind of is constantly falling apart, people just aren't going to use it, and it's going to go down as that thing that didn't really work well and is forgettable at best. Another challenge, you shouldn't affect the main site. So we all have this other thing called Reddit.com that is going on, and people are still using that, and some of them don't even know this is going on. So we're using some of the same infrastructure, and so we have to avoid actually taking down the main site so that we can still get to do these fun projects every year. And just because we like our users and we want to keep the site up for them. Another point, so this originally started out with maybe 3 people working on it and a PM. So it's a really small team, and this was none of our main projects for the actual, for the duration of us working on this. So we all had other stuff to do, again, on Reddit.com, and so we had to balance that. And then finally, this is less of a technical challenge, but this was definitely what stressed our PM out the most, is when you launch this thing, you have no clue what people are going to do with it. So the internet being the internet, sometimes they tend to be graffiti artists or vandals. Sometimes they put nasty stuff up there. So there's a chance of this making Reddit look really bad, or even worse. And then it's a small team. You don't have a ton of time to work on it, and you have a chance of bringing down the main site and making everyone look bad, making yourself look bad. So you don't have a lot of time to work on it. So no pressure. That being said, it did go pretty well, so I'd like to talk a little bit about how we actually just did the development workflow. Even though we're probably all in software and we probably have our task management system and stuff like that, we did a couple of unique things here just to keep it fun. So that's one of our goals when we're doing this, is it can't feel like actual work. So one of the things our PM Josh does is, for the last couple of projects, is we track our stress levels over time. So this is just kind of a self-reported metric on a scale of 1 to 10, and each week we just come in and say where we are or how we're feeling. And so this is I do feel like this is useful when you're sitting in the room with people. So these names don't maybe mean anything to most people here, but you sort of get a sense of, okay, the back-end people are getting a little more stressed. Maybe they need to put more time into it. Okay, mobile people aren't stressed at all. That's probably going to go pretty well. Some people, that red line at the top is our PM. He never was unstressed because he has no clue what's going to happen. I think he always says best case scenario for him is that the tech doesn't work at all and it all falls apart. Because then, well, he tried. He did his part. So, but for us, it's it's the opposite kind of. And then some people, that blue line at the bottom, B Simpson, who's here somewhere. He's just always cool as a cucumber. So I wish I could be like that. For actually managing the tasks, we use a really complex system called a spreadsheet. And so we use Jira for tracking stuff normally at Reddit.com. It's a little more formal, but we really don't want the formal aspect of that, and it feels very overweight or heavy-handed for something like this. So we just drop our tasks down on the left, and we highlight them in green if we're done, and then we do a cross-through if we don't want to do them, and anyone can put anyone's name down, or you can put your own name. And one of the things I really like about this is we can be super goofy at times. So one of these tasks here is a client buffering thing to do. And so I don't know if you know what that means, but I don't know what that means. And I'm pretty sure Matt forgot what that meant a week later. And then a couple days after that, he remembered and he figured it out and he got it done. So this system works because we all kind of have the ability to self-manage and self-prioritize, and we don't really need to be necessarily putting in full specs and tasks, and when we can just sort of figure out what the most important thing is and do it. And one final thing, when I was making this slide, I came across this one. So this is definitely not something you can put in Jira. So it says, title cursor relationship fills off, assigned to Matt, and then someone came back in later and wrote, Josh is idiot. So I would definitely never write that in Jira. But it turns out that actually Josh wrote that. He realized he was an idiot. So, there you go. Okay, so let's see the actual tech stuff. We'll start with a quick overview. So there's basically 2 things that went on at a high level. So when a user first showed up to the page, we started by rendering the full board for them. And what that allowed us to do is, so we do the initial board rendering and then we start overlaying real-time updates as they come in. So in this situation, the client makes a request for the board. If it's cached by our CDN Fastly, then They return it, and everything's great, and then they render the board. If the cache is stale, the request falls through, hits our application server, and we serve it directly from Redis. And we'll talk about the structure and all that later. So that's kind of a very simple use case. The TTL on this we set to 1 second, so we always want it to be relatively fresh so that we could, obviously it's the best real-time experience. We want people to have a very real-time experience. Okay, so this is the more complicated part. And so this is when people are actually setting a pixel. So here you can see a few things happen. The first thing, let's say Joe Schmo wants to write a pixel at 500/500, a blue pixel. That request comes in, and it immediately, it first goes to our WebSocket servers. So it goes through a fan out exchange in RabbitMQ, where we then publish that to WebSockets and back to the user so they can get that pixel updated in real time. And that just gets overlaid on that board. Second thing we do is we send an event to our event collector. So this is basically just kind of a horizontally scalable set of applications that then forward that along, queue up locally and forward along to a Kafka pipeline. We use this a lot for events at Reddit in general for doing like more complex analysis like A/B testing and stuff. But for here, our most complex idea was that we want to make a GIF of it at the end. And so our users did that way before we released this, but the idea here was at the end we could have a full data set that we could publish to them, and then they could do all kinds of really cool stuff with. Since a lot of them, it took a little bit of time after it started to actually start capturing the board state changes. So this was just sort of a public data set that we released. Third thing that happens is we actually write just the color information to Redis. And so that's what we'll be talking about the most. No author information at all. And then finally, we write the author information, the color information, all of this stuff to Cassandra, and this let people click the individual pixels to see, okay, Joe Schmo, our good friend, placed that at 500/500 9 hours ago or whatever. And so then you could go back and see if your pixel was still there or if your friend's pixel was there. Okay. So before we get too much into the Redis stuff, I'd like to talk about how we even made the decision to choose Redis. So you notice Cassandra is in the mix there. For us, like we use Cassandra a lot at Reddit, so it's quite a mature solution. Our initial MVP of the project was in Cassandra, and this was when we were doing like employee testing and just testing of our own. And so it has the pros for Cassandra are that our cluster is actually really large. So it's 36 nodes. We have a total of about 96 terabytes of data. Throughput's pretty good, 90K reads a second and writes a second. So anytime we do a new project, we're gonna wanna tend to use this just because we know how it works. We have experts in-house that wanna use it, that know how to administer it. And so that was our initial inclination. The downsides of this are it doesn't really fit the project's data model well. And so I'll go into that a little bit more. If anyone here is familiar with Cassandra, essentially what we had was we need a way to address individual pixels. So we had each coordinate was a column, and then the value was a pixel color. So the problem with this is we have to then scan literally 1 million columns to get that information back. So we had this sort of inclination that it wasn't quite right, but if we can use it, then we want to use something stable. The other downside is, back to that original challenge, we don't want to affect the main site at all. So if we can avoid using our main data store, then that might be an upside. Because then even if this project falls over, we don't ruin the rest of Reddit.com. And so we started evaluating Redis for this as well. And some of the upsides that we were thinking is like, again, it fits the data model really well, which we ended up using Bitfield. It doesn't affect the main site, so if it falls over, we don't affect Reddit. Downsides, so we don't use it a lot. Right now, if you go to Reddit and you go to a particular subreddit, you'll see in the sidebar it shows how many people are active. So we use Redis for counting that. Recently, we started a new project for tracking view counts as well, which we use Reddit for, but it's not a lot of like super production critical stuff. So we don't necessarily. We just personally haven't used it much. So that being said, we were initially leaning Cassandra, and so I'd like to talk a little bit about how we went into making the choice for Redis and going with Redis. So, yeah, so before we get into that too much, I'll kind of go in the chronological order of how we made the decision. And that kind of started with us imagining what better data structure, like our ideal data structure looked like. So in this situation, I'll go over this kind of slowly so hopefully everyone gets it. I think it's pretty conceptually simple, but so basically what we have here on the right is an arbitrarily scaled down grid for the sake of this, this example. So it's a 2x2 grid in this case rather than a 1,000 by 1,000. And then the actual data structure that we use is on the left. So originally, we were storing a full like 256 set of colors, so it was 16 million technically was the color choice. But even in the MVP, we had always only had a small palette that you could choose from. So we knew like it might be okay if we want to make a trade-off to say, okay, let's limit everyone to 16 colors if we can store that more efficiently. So that's what we ended up doing. So what this allowed us to do is take 4 bits, basically a 4-bit unsigned integer, and store the index of the color in those 4 bits. So the front end could then take that value of 0 through 15 and translate it to red, for instance, or yellow, or whatever we decided on. As for how this is actually, so that's sort of, yeah, that's the overall format. The way that we actually display it is we essentially take that bitmap, so that series of unsigned integers, and we kind of overlay it onto the grid. So you'll see the first 4 bits corresponds to the red. We move over 1, we correspond to the yellow. Once we reach the end of the grid of the canvas, we wrap around and continue drawing. So we just basically pass this to the front end as is, and then they display it. The front end does the work of displaying it. When we actually want to write, all we have to do is use our sort of application logic, knowing what coordinate we want to write to, and we can calculate the offset that we need to write to inside the bitmap. So in this case, the formula is, for this one is x plus 2y, so that 2 comes from the canvas width, so we just need to take that y value, figure out how many rows down we need to go, and then go in by the x value to get the final place in the bitmap we need to write. So that seemed pretty cool, and that seemed, the great upside about this is now, beforehand we were thinking like, if we have to do this losslessly, like we can't do like JPEG or something like that. We were thinking we're gonna have to transmit many megabytes to get this done, and now we've cut 1 million pixels down to a nice 500 kilobytes. And so then we can gzip that in the response as well and get it even lower. So this was like, at this point we felt like this would be good if we could do this. Okay. So we started looking at Redis because we do have it around, and a few of us have used it at different places, but we wanted to see if it had anything that it could offer us, because ideally, like maybe we could fit this in one key, and then if we could just modify those bits precisely, then we would get what we wanted. So we started looking at setBit, and so if you're unfamiliar, setBit looks like this. So all you have to do with setBit is say your key, say your offset. So in this case, you would say how far in to the bitmap you wanted to write. And then for the value, you would just say 0 or 1, so the individual bit that you wanted to write. So, okay, this looks pretty good. There's a downside. So like, let's say we wanted to write 1 color. So in this case, I picked 15, so that would be all 1s. So we have to do a few things. First of all, we have to do the command 4 times. We have to increment the offset ourselves. In this case, that would actually be the 25th pixel, so we have to multiply that by our integer size, so we get to 100, whatever. These are not hard numbers to do, but it just seems like a lot of overhead. The other downside of this is like by having 4 different commands, if someone else were to try to write this pixel at the same time, they could easily clobber it, and we would get sort of like a weird state. So like maybe someone's trying to write a red pixel, someone else trying to write a blue pixel, and then they stomp over one another and we get a black pixel or a white pixel or something. So in all, like that's not that bad of a trade-off, and I kind of like think it's kind of cool that would happen if people are like contesting and it turns into something random. But we didn't end up going with that. We looked around a little bit more and we found out, oh, and also I'm assuming we could also use like transactions or pipelines or something like that to avoid that problem. So that was in the back of our mind as well. Then we came across something better. So something that is just absolutely perfect for this use case. And so it's Bitfield. And what Bitfield lets you do is basically say your key, say you want to set, or you can also get your individual integer. And then you basically specify your integer size. So in this case, it's an unsigned 4-bit integer, which we talked about earlier. And then we can say our offset. And the cool thing that I like about this is that we can actually, if we put that pound sign in front, we can actually, it will do the math of multiplying that by our integer size. So it's a nice little extra interface thing for us. So like if we wanted to change the integer size later, we wouldn't even have to change that part. But as you can see, it's not a lot of code anyway. So that was the other really cool part about it is my comment there is longer than the actual implementation. So, and that's just me basically explaining exactly what I'm explaining now. So, yeah, and then we can also just say 15 instead of coming up with the bits ourselves. So it's nice, it just makes the code a little bit cleaner. And then on the get path, so now for actually displaying this back to the user, don't get overwhelmed by all the stuff on the right. The actual thing that we have to do from the backend's point of view is just a simple get command. So we can just return the entire key back. And then on the front end, for this particular case, the only trickiness here, I hope everyone can see the yellow there. So because JavaScript doesn't have a notion of uint4 arrays, we have to just parse it as 8-bit integers, and then get the left and the right pixel by doing some bit shifting and bitwise operations. So either way, very simple implementation. Most of that deferred stuff is the complicated thing. Okay, so at this point, we had an implementation in Redis, and we had an implementation in Cassandra. But before we're really even going to consider like whether we would use Redis, we need to make sure it's going to handle the load that we're expecting. So again, like I said in the beginning, we're expecting, based on last year's April Fool's project, something like 100 to 200,000 people using it at a time. So we were looking for numbers that ideally went far beyond that. So the good thing is, in our initial load tests, we found that we were getting about 180K writes a second. Initially, we were bound on network, and the CPU was like not really doing much. And so I realized that we were using a smaller instance than we need to. So our initial numbers we just kind of scaled up because they were beyond what we expected anyway, or what we needed. So yeah, so we got about 180K writes a second. Just to put that number in context, all of Reddit.com doesn't get that much. So the idea here is that even if we got anywhere near that, we're going to hit some other bottleneck first, DB connections or something like that, which are much higher than what Reddit does, but we're still using some of the same infrastructure. So this felt very good. And so we almost called it quits here. This seemed like, okay, yeah, Redis is great. Let's move on. And then someone mentioned the idea that, hey, we're not just going to be writing pixels. People are actually going to want to view the board at some point, which is a crazy concept. So yeah, maybe we want to do this load test with like a mixed workload, essentially, so reads and writes. So interesting thing happened. We mixed in some reads. So I think initially we had mixed in something like 10 reads, and it was weird. All of a sudden we were dropping, we were losing 20K writes a second. And so I slapped myself on the forehead, like it's very obvious right after why that is the case. And so yeah, the ratio is about 1 to 2,000. The problem with this is that whenever we're writing, we're only writing a single pixel, whereas whenever we're reading back 500 kilobytes. So in my mind, both of those numbers are pretty small, or the 500K is pretty small. It's not a lot of data, but as far as just the ratio of those, it is very real. So. And if you're wondering why it wasn't a ratio of like 1 to 1 million, it's things like the overhead of the ASCII command going to Redis, the TCP, stuff like that. So if we're network bound, those things come into play as well. And here's a very technical graph I captured at the time of this load test, where you can see this in action. Yeah, I didn't capture anything, and then I destroyed the instance, so I can't even go back and look. So next time I'm going to think about this in the future, that people might want to see that. Okay, so at this point. Yeah, one last thing to put that number into context. If we're thinking of 150,000 people using this at a time, and we're thinking that they might place a pixel once per hour, then 180,000 writes a second is fine. But as it turns out, we ended up launching with a lot less than an hour. So originally the plan was once per hour. So we wanted to over-engineer it. So at this point, like we could literally have all people writing once a second, and Redis would be fine. But the one last thing that I almost forgot was, based on that read test, we realized the need for caching. So we said, maybe we don't want to just have every read follow through to Redis. It's kind of inefficient, and we're fine with a little bit of latency anyway, or a little bit of a slightly old board anyway. Okay, so at this point, believe it or not, we still were not convinced about Redis. Again, we have this infrastructure that we already know about, we already use constantly. It's a huge cluster that's worked well for us. So again, we have an implementation. We've proven in theory that Redis might work, but in practice, like why be risky when you don't have to? Well, this is why. So we did another load test. So at this point, we'd only been doing I'm going longer than I thought. At this point, we'd only been doing employee testing, and there was like 20 people. So the board was not filled with very many pixels at all. So at this point, we filled it with 1 million random pixels, and we came to actually load the board down. Previously, it had been loading quite fine, and at this point, the Cassandra's load time to get to the full board was over 30 seconds. So that looked pretty bad. I mean, we can handle a second of stale data, but not 30 seconds. That's kind of unrealistic. And so we did the same with Redis, and I'm assuming a lot of people here with Redis that have used Redis can probably guess how long it took to retrieve a single key. It was quite fast. So I would say that this, more than anything, cemented the decision to go with Redis. And if nothing else, so we were going back and forth on this for like 2 or 3 weeks. If nothing else, I personally learned the value of just having numbers to win arguments. So this was the final thing that was important. Okay, so the last thing we'll talk about is caching. So as I talked about earlier, whenever we were doing that initial load test, we found the need for caching. And so what we ended up doing here was going with a sort of multi-tiered caching system. So I'll go through each layer. And one of the takeaways here is they were all very simple to implement. So the first line of defense that we used was our CDN Fastly. To actually implement this, it was simple as adding a cache control header. So we set the staleness to the TTL to 1 second, and that was all that it took for us. So in theory, what this should do, and we talked with them about it, this should limit the number of requests that fall through to the number of points of presence or data centers that they have, because they should keep a copy of it in each of those. So we looked on their website, we talked with their support, which is really good, and that should be about 30 a second. And that's what we ended up seeing, so that was good. So as a second line of defense, we have, on all of Reddit's application servers, there's a local cache, so it's a memcache instance. We could probably use Redis too, though. But basically, this is the idea here was maybe Fastly will, maybe they're not used to 1 second timeouts, and they'll have to, maybe more requests will fall through, or maybe data will get stale, and maybe we'll have to fall back to that local cache. And then finally, if none of that happened, we fell back to Redis. And in this case, Redis was kind of a cache, even though we ultimately was treating it as a source of truth. We had a backup plan where we could, so we talked about the implementation. We had a backup plan where we could actually load in from Cassandra in case Redis restarted, or the instance got retired, which sometimes happens with AWS unexpectedly. And then the final thing here you'll notice is for each one of these layers, we were controlling all of this via get parameters. So the idea here was, if things are falling apart in production, we want a really easy way that we can control these different layers without having to worry about hot patching and coming up with patches. And that's like a key thing that we use very frequently, is having a way to control this stuff. And the idea here is also the front end maybe could even do some logic on its own, be smart and see it's getting an old board, and then request a less cache version. We didn't end up doing that at all, though. So here's the actual request per second that fell through. So our CDN worked great. So this is what ended up hitting Redis in terms of reads. Okay, so I'm pretty much done. A few takeaways. Have knobs you can tune, switches you can flip. So in this case, we had all of that, those get parameters in place. We didn't end up using any of them. But one of the things I didn't get a chance to talk about, and is in the blog post if you want to try to find that, is one of the knobs we did tune was changing the actual cooldown timer. So if you play, you probably remember that. I'm very sorry. But our RabbitMQ cluster was kind of becoming problematic, and so we needed to relieve some pressure. And so changing that timer was sort of it let people still play the game with and us do the maintenance without having to ruin it for everyone. Yeah, load test everything with real world data. So in this case, load testing Cassandra showed us that we need to use Redis. Load testing Redis showed us that maybe we should do some caching. And then the thing that we ignored was that we should have load tested was our RabbitMQ a little bit, but it was a new, it was a different type of load, so we didn't really expect it. So yeah, and the other key thing is here is use real world data. So had we just done simple gets and sets, we wouldn't have seen that size disparity and seen that we needed caching maybe. Okay, use power principles. So this is just basically like, again, this is like 3 people working on this for the longest time. And so basically like you have to do things that give you a disproportionate amount of impact for the effort that you put in. And then finally, some things you think will matter, some things you think will matter won't, some things you don't think will matter will, some things you think will matter would have mattered, but you'll never know they mattered because you did the thing that prevented them from mattering. So again, some things you think will matter won't. We also wrote every single pixel to Cassandra, and I was like, let's get rid of that, and we didn't get rid of it, and it wasn't a problem. Some things you don't think will matter will. Again, we didn't even think about Rabbit being a problem, it was. And finally, on that last long point, we did a whole bunch of other stuff that made it run really well, and because we didn't get the signal for things going wrong, we'll never know. It all just kind of worked out well. So I think that's it. I think I might have run over time, I'm sorry. But thanks everyone.
Did you do
time? So stop me if we don't have time, or I don't know.
Did you do rate limiting in Cassandra or Redis?
The rate limiting that we use is based on we have that stored in Memcache. So, any other questions?
I was really curious about that stress graph you had.
Oh, okay.
Is that a thing that's been long-standing at Reddit, or just for these sort of side projects? How did it start?
Yeah. So basically, as far as I know, it's only on these projects. So it's not a standard thing at Reddit. I think it's been used. I don't know for sure how many years, but we definitely used it last year. So I've only been involved in 2 April Fool's projects. But yeah, none of that development workflow is standard at Reddit at all. So it's just for these. It's fun to keep it light. Cool. Oh, yeah.
So if you used Bitfield, did you just have one key for the entire
Yep.
field? And if so, did you just have one Redis box, or you use Sentinel, or what kind of replication?
One Redis box. We had a backup in case things went wrong, but based on our and a way to load in from Cassandra. But yeah, basically we had 2 boxes, and we were planning on maybe failing over if something went wrong with the other. But yeah.
Thanks.
Okay, I think that's all the time I have. Thank you.